So what I want to talk about now is ATP, adenosine triphosphate. So this is really how we shuttle energy throughout our bodies. And I want you to realize that if we go back to macromolecules, this is actually a nucleic acid. If you think about that, nucleotides are made up of three components. One is a pentose sugar. So here you can see our kind of in pink as our pentose sugar. This one is ribose. Also the sugar found in RNA. Then phosphate group, and ATP has actually three phosphate groups attached to each other. And then a nitrogenous base, and here we have adenine. So it has the three structures. And so what we're going to talk about is really kind of the breakdown of ATP, the hydrolysis of ATP. And so here you can see water is added, hydrolysis. And then what you end up with is ADP, adenosine triphosphate, plus the extra phosphate and energy. And that is, again, the 7.3 kilocalories per mole, or a negative 7.3 kilocalories per mole from the last little video. So what I want you to make sure you understand is really what we're doing most of the time is we're passing ATP back and forth. We're shuffling it. What we're doing is that we're breaking this bond right here over and over and over again. And that bond is actually called a phosphodiester bond, which I don't believe I said in the earlier ones, but I'm sure we'll talk about or have talked about, depending on when you're watching this in the Zoom session, phosphodiester linkage. Okay. All right. So what we want to do then is kind of look at what's happening. So what we do is we use ATP kind of for energy coupling. So we're going to build this molecule. We want to put these together. And so what we're going to do is we're going to actually add ATP. ATP comes in. There's the phosphate that's been added. It's phosphorylated. That's just a phosphorylated, just means a fancy way of saying adding a phosphate. And then what happens is the NH2 comes in and it connects. And you can see that it takes a little bit of energy to do that. There's the negative 7.3 kilocalories per mole. And then you have a net delta G of a negative 3.9 kilocalories per mole. So that would be given off as heat in this little tiny reaction. All right, so anyway, just to get kind of an idea, don't memorize this by any means. What I'm trying to get you to do is look at this process and what's involved. And just to make sure that you are aware of how ATP is working. Okay, so what happens is the ATP is actually necessary for things like transport proteins, where you're moving some kind of solute across the membrane, which we'll talk about. Or getting something to move along a cytoskeletal tract, which we haven't talked about yet, but this is a vesicle inside the cell, and this is part of the cytoskeleton. And to actually physically get it to move, you have these little motor proteins right here, and they need ATP to actually have them shift so this thing can move down the skeleton. So anyway, what I want you to realize is ATP is really pretty much doing adding energy or for work to be done. All right, and then this is the ATP cycle, and I hate this picture. I don't. It needs more. Okay, so you have ATP plus water comes back down here, and it breaks down to ADP plus phosphate. The I stands for inorganic. This actually gets added back on. It goes to ATP. So if you're adding this, okay, well, let's do it this way. You got ATP plus water, okay, which basically is then you are breaking off that protein or phosphate. This is actually on this side would be hydrolysis. So on this side then, which it doesn't really show, because it would be releasing water, but this would be dehydration synthesis or dehydration reaction or condensation reaction. Okay. The other thing that I don't like about this is if you see here this big yellow arrow, it says energy for cellular work. endergonic energy consuming processes. So what I want you to think about going from here to here, what kind of reaction is this? Well, this is not endergonic, which this makes it look like it is. This is actually exergonic. So that energy is being released, and that release then is going to do endergonic work. Okay, so energy from exergonic activity. So this is something releasing energy, but going from here to here, this is an endergonic process. So I almost feel like endergonic should be written here. Exergonic should be written here. Dehydration synthesis should be written here. And hydrolysis should be written here. So I'm not 100% happy with the way this one is written up. Okay, so anyway, that would be it for the ATP cycle.